Have you ever found yourself wrestling with an AI? Not just for information, but getting that information in a really specific structured format.
Oh, absolutely.
Like something clean, organized, ready to plug right into another system without you having to manually sort of pick through it.
Yeah, it's a common headache, isn't it? You get this beautifully written response, maybe, but then you've got to painstakingly sift through it just to pull out the exact data point you actually need for an application.
Exactly. It's like asking for, I don't know, a flight departure time.
You're right.
And getting a lovely description of the clouds, but still no actual time.
Precisely. It might be nice to read, but it's useless for your calendar app. Not
All right.
actionable.
That frustration, yeah, we've all been there. And today on the Deep Dive, we're actually going to tackle that exact problem head on.
Good.
Our mission is to take a deep dive into JSON prompting. We want to unpack what this is, why it's becoming, well, not just useful, but pretty indispensable in the world of AI.
Indispensable is a strong word, but yeah, I think it fits.
And crucially, how you, the listener, can master it to get the most precise, actionable outputs from large language models, like Anthropic's Claude, for instance.
It's vital because it really acts as the bridge. It connects the AI's intelligence to practical application.
Okay, the bridge. So where are we getting our info for this?
We'll be pulling our insights mainly from Anthropic's own documentation, things like their guides on tool use, prompt engineering techniques,
Right?
and also just looking at some broader machine learning system concepts. It's about understanding the how and why behind making AI outputs useful for other software, moving beyond just chat.
Okay, so whether you're out there building an AI agent or maybe integrating AI into your existing workflows, or, even if you're just curious about how developers get these incredibly smart AIs to play nice with other software, understanding JSON prompting really sounds like a game changer.
It absolutely is.
So let's unpack this, starting right at the beginning. When we talk about JSON prompting, what's the core idea? What are we actually defining here?
Okay, so at its heart, JSON prompting is it's about explicitly instructing a large language model, telling it to generate its entire response only as a JSON object.
Only JSON.
Yes. And crucially, it has to stick to a predefined structure that you give it. So you're not just asking for information anymore, you're dictating the exact data schema of the reply.
Okay, so it's like setting up a contract.
Exactly. A very specific contract between your prompt and the model's output.
So it's a shift from tell me about X to tell me about X, but only in this specific JSON shape. That feels like a pretty significant distinction.
It is.
Can you give us a concrete example? Like how would you actually write a prompt to get Claude, say, to give you that specific JSON shape?
Sure. Let's take a common scenario. Maybe you're building a content moderation system.
Okay.
Instead of getting back a paragraph describing potential violations, which, you'd then have to process somehow.
Right, parse it.
You can prompt Claude directly, something like, respond with only a JSON object using the format below, and then you literally provide the format like violations message out, list of violated categories.
Wow, okay. That's incredibly precise.
It is. It tells the model exactly how the output should look, specifies the top-level key, violations in this case, says it expects an array of objects inside that, and then dictates the structure of each of those objects, like the id and categories keys. It's not a suggestion, it's really a command for the output structure.
That level of precision is,
Yeah,
really powerful. But why JSON specifically? What makes JSON the go-to format here? Not, I don't know, XML or even just a comma-separated list.
That's a great question. JSON's utility, I think, comes down to a few key things. It's lightweight, it's human-readable, well, mostly.
Mostly, yeah.
But critically, it's very easily machine-parsable. That's the key. It makes it incredibly straightforward for different software components to talk to each other.
Like a common language for data.
Exactly. When an AI outputs in JSON, another program can just read it, interpret it, and act on it without needing complex and often kind of brittle natural language processing to figure out what's what.
Okay.
It's like having a universal translator just for data. Cuts down ambiguity, reduces processing overhead. It's just efficient.
I can definitely see the efficiency gain there.
Yeah.
I mean, how many hours have people spent trying to write regex patterns to pull data out of text?
Too many.
It really highlights why structured outputs are so critical if you want to move beyond just conversation to, well, actionable intelligence.
Right.
But some people might still think, well, NLP is getting really good. Can't we just use more advanced NLP to extract what we need from a normal text response?
Yeah.
What's the limitation there?
It's a fair point, and NLP has made huge strides. But the need for structured outputs, especially for integration and automation, really boils down to reliability.
Reliability. Okay.
Yeah. The main reason is making AI outputs directly actionable for other software. Natural language, just by its nature, is often ambiguous, right? It's nuanced, open to interpretation.
Hmm.
Even the best NLP models can sometimes misunderstand or just completely miss a piece of information if it's not laid out clearly. But when an AI responds in a predictable JSON format,
Hmm.
well, another program can confidently read and use that data. There's no guessing, no need for complex heuristic rules, and frankly, much less risk of error.
Right. It's about getting deterministic results for those downstream systems.
Predictability.
Exactly. Predictability and reliability. Minimizing that guesswork.
Okay, that makes a lot of sense. And it makes me think about AI agents, the ones that need to use tools or interact with other systems. How does JSON fit in there? Is it still just about the data structure?
Ah, this is where JSON's role gets even more interesting, I think. It goes beyond just data output. For AI agents, structured output is absolutely critical for seamless tool use.
Yes. Well, when a model like Claude needs to interact with an external tool, maybe query a database or send an email or hit an API,
Okay.
it often needs to output a structured call in JSON format. The Anthropic docs actually mention things like input JSON delta and Toulouse content block delta events.
Deltas, so like chunks of JSON.
Yeah, exactly. It suggests Claude outputs JSON in pieces when it's figuring out how to use a tool or actually using it. This structure allows the system around the AI to understand precisely which tool to use, what parameters to pass to that tool, and the exact format for those parameters.
Wow.
It turns an abstract intention, find the weather, into a concrete executable action, call weather API with location London, date today. It's fundamental for building autonomous AI systems.
That's a huge leap from just generating text. It's like the AI isn't just talking, it's commanding things using data, coordinating action.
Precisely. It's coordinating. And for larger scale stuff, like, say, processing hundreds of thousands of requests, is JSON still the best way there?
Oh, definitely. For handling multiple requests efficiently, particularly in batch processing, the results often come back in .json format. JSON lines. JSON lines. Okay, what's
It
that?
just means each line in the file is its own complete, valid JSON object. So each line represents the result of a single request from your batch.
Ah, okay. So one line, one result.
Right. It ensures you get consistent, structured data across all those operations, makes it super easy to process results at scale, maybe in parallel. If you send 100 requests to classify content, you get back 100 distinct JSON objects, one per line.
Neat.
And often, these include something like a custom field you might have sent. The insight here is that this format lets you immediately process results and easily match them back to your original requests, even if they finish out of order. It's built for robust, high-throughput data pipelines.
Okay, so we've really established the what and the pretty profound why behind JSON prompting. That precision is clearly the key benefit. But for anyone listening who's thinking, okay, I'm sold, I need this, the next question is always, how do you actually get these perfect JSON outputs consistently from an LLM? It feels like it could be tricky. Part art, part science.
It definitely feels like a blend sometimes, yeah. It's the art of clear instruction mixed with some careful prompt engineering.
Okay.
It really starts with being explicit, just like in that moderation example. You have to tell the model what you want, respond with only a JSON object, and then, crucially, provide the schema you want it to follow.
Right, direct.
That clarity is paramount. If you're vague, you leave too much room for the model to interpret, and that's where you get unreliable outputs.
Makes sense. Being explicit is step one. Are there other, maybe more subtle ways to nudge the model towards JSON?
Yes, and this is where it gets kind of fascinating. The model actually picks up cues from the rest of your prompt. The source material highlights this. It says, the formatting style used in your prompt may influence Claude's response style.
Ah.
So what that means is, if you want JSON output, it actually helps to structure parts of your input prompt using JSON-like elements, or maybe use XML tags to clearly mark off sections, especially where you define the schema.
Like JSON output tags or something.
Exactly. You could wrap your schema definition in tags like that. It subtly teaches the model the desired output style, reinforces the expectation not just with the command, but by example within the prompt itself.
That's clever. Kind of leading by example in the prompt, showing it the grammar you expect.
Precisely.
And speaking of examples, does actually providing a few complete examples, input and output directly in the prompt help too?
Oh, absolutely. And the documentation basically calls this a secret weapon for getting reliable JSON.
A secret weapon. Okay, tell me more.
Providing A few well-crafted examples in your prompt, this is often called multi-shot prompting, dramatically improves accuracy, consistency, and quality.
Multi-shot, right.
Yeah.
Showing it multiple turns.
Yeah. If you want JSON, show it several examples of good inputs paired with the kind of well-formed JSON outputs you expect for those inputs. It helps Claude, or any LLM really, understand the pattern much better than just describing it. It's remarkably effective for calibrating the model to your specific needs.
I love that show. Don't just tell. Makes total sense.
Yeah.
What about giving the AI a specific role or persona? Can setting that up help keep it focused on JSON?
Definitely.
Yeah.
Using a system prompt to give Claude a specific role can further constrain its behavior. You might tell it, for example, you are a customer support ticket classification system. Your only job is to analyze tickets and output their category and priority in JSON format.
Okay.
This puts the model into a specific mindset. Structured output, like JSON, becomes its natural mode of operation for that task. It helps streamline its focus.
And for really complex stuff, where the AI needs to, I don't know, think things through before outputting the JSON, can we guide that thinking process too?
Yes, and that's a more advanced technique, but very powerful. You can leverage Claude's ability to think step by step
How does that work?
by guiding its initial or interleaved thinking. You might ask it to outline its reasoning steps first, maybe in scratchpad tags, before it generates the final JSON.
Okay, like showing its work.
Exactly.
No.
It helps the model organize its internal logic, especially if it involves multiple steps or using tools before it has to construct the final structured response. It leads to more accurate JSON, particularly for complex tasks.
Got it. So, okay, we've seen how JSON really changes what an LLM outputs, but you've hinted that its influence goes way beyond just the model's response. It seems like the structured language is kind of the unsung hero, the workhorse throughout the whole AI development process. Can we broaden the lens a bit? Where else is JSON playing this pervasive role in the AI ecosystem?
Yeah, absolutely. If you zoom out, JSON isn't just for the AI's output, it's also fundamental for configuring the tools around the AI. Think about setup files, parameters.
Like configuration file.
Exactly. For instance, the Claude Code CLI uses .mcp.json files for project settings and .claude.json for global settings. And what's really neat is that these JSON config files often support things like environment variable expansion, meaning you can put placeholders in your JSON config, like API key, and it will pull the actual value from the system's environment variables at runtime.
Ah, very useful.
It makes configurations flexible and dynamic.
Yeah.
You can adapt your AI setups for different environments, dev, staging, production, without hard-coding secrets or rewriting files. It's crucial for making AI systems adaptable and secure.
That's a great point. Adaptability, security. Essential for real-world applications.
Yeah.
And zooming out even further into the broader world of ML, like machine learning operations,
Yeah.
where does JSON fit there?
Oh, it's absolutely everywhere in MLOps. You can think of it as the fundamental language for accountability and collaboration in machine learning projects.
How so?
Tools that track things like experiment results, performance trends, metadata, training lineage. The sources mention tools like weights and biases or MLflow. They all rely heavily on JSON.
To store all that tracking data.
Exactly. When a data scientist logs an experiment or registers a model, all that associated information parameters, metrics, dataset versions, the model artifact location gets meticulously serialized as JSON.
Okay.
The key insight here is that JSON provides this universal machine-readable format. It ensures a clear chain of custody for every piece of data, every experiment, every model version. Without it, traceability and reproducibility, which are pillars of good MLOps, would be incredibly difficult.
Right, you need to know exactly what went into training a model if you need to debug it or compare it later.
Precisely. It allows engineers to confidently debug, compare models, roll back if needed. It helps organizations meet auditing or regulatory requirements, too. It's the glue holding that MLOps lifecycle together.
So it really is the lingua franca for structured data in the AI world, from the prompt to the output to the configuration to the tracking.
Pretty much, yeah.
Okay, but for all its power, it can't be all smooth sailing, right? What are some of the challenges or maybe just considerations developers should keep in mind when they're working heavily with JSON prompting?
Yeah, no, it's not without its quirks. One subtle thing, especially if you're building something real-time or user-facing, is that generating JSON via streaming can sometimes introduce small delays.
Delays, why is that?
Well, the documentation mentions delays between streaming events while the model is working. Think about it. The model can't just stream out characters randomly. It has to build valid JSON structures.
Ah, Right. It needs to complete a key value pair before sending it.
Exactly. It needs to accumulate those complete pairs or maybe even small nested objects before it can emit a chunk of valid JSON. This can lead to slight pauses that might be noticeable to an end user, unlike just streaming plain text.
Okay, that makes sense. It's building a structure, not just a sequence of words. What about the complexity of the JSON itself? Does making really complex schemas cause problems?
That's definitely another consideration. The more complex your desired JSON schema, lots of nesting, different data types, conditional fields, the harder it can be to get the model to produce perfect output consistently.
Yeah, I can imagine debugging a missing comma deep in a nested structure generated by an AI.
Oh, I've been there. It's like teaching someone to draw perfectly within very intricate lines. It often requires more sophisticated prompting, maybe more multi-shot examples, definitely more rigorous testing to ensure reliability.
And I assume token costs are still a factor.
Absolutely. While the source says token counting is free to use, meaning, checking how many tokens your prompt uses the actual generation of JSON tokens still costs money based on usage.
Right.
So a very verbose or deeply nested JSON output will naturally consume more tokens than a simple one. That's an important factor for high-volume applications where you need to be mindful of cost efficiency.
This has been a really, really insightful deep dive.
Hmm.
We've seen how JSON prompting takes these large language models
Mm.
and transforms them from just, intelligent text generators into genuinely powerful programmatic engines.
Hmm.
It really highlights that it's not just about what the AI says, but fundamentally how it says it. That structure enables seamless integration, sophisticated tool use, efficient data handling. It touches everything in the AI ecosystem.
It really does. It's that critical bridge, like we said, between the LLM's conversational ability and the structured demands of software. Understanding and using it lets you unlock a whole new level of precision and control. You can move AI from being just a conversational partner to being a truly functional, integrated component.
So thinking about the future then, as these AI systems get more sophisticated and they start interacting more and more with each other, what happens?
That's a fascinating thought.
Imagine a future where AIs are primarily prompting each other,
Yeah.
maybe using highly structured formats like JSON almost exclusively for their internal communication.
An AI to AI communication layer built on JSON.
Yeah. How might that reliance on precise machine-readable language shape how AI reasons or how agents collaborate? Could it even make their internal workings, well, more opaque to us humans?
It's a really interesting question. Will their internal language become something we can't easily interpret? It's definitely a thought-provoking direction for AI and certainly something to keep an eye on as these systems continue to evolve.